So I'm going to walk you through the retake. That's your homework to prepare you guys for the actual retake if you take it tomorrow during advisory, or just extra practice for those of you who already understand it. Okay, let me share my screen. All right, here we go. So number one says a 6-liter sample of nitrogen gas is initially at a temperature of 200 Kelvin and 2 atmospheres. If the volume decreases to 3 liters, and the pressure increases to 3 atmospheres, what will be the new temperature? So what you guys are going to do is use PV over T equals PV over T. Okay. Plug in your numbers. So you have 2 times 6 divided by 200 equals 3 times 3 divided by X. I think a lot of people struggle when X is in the denominator. So be really careful with that. What you're going to want to do is multiply both sides of the equation by X, right? So I put X right here. Okay, so you can see I did, 2 times 6 is 12. And then 3 times 3 is 9. Okay. And then you're going to be dividing by whatever's next to X. So divide by 12. So you can see the work is already done. It's a little weird. And then X is going to equal 150. You're solving for temperature. So the units are going to be in Kelvin. Number 2, what pressure does 3 moles of a gas exert if it is in a 2-liter container? That's what it should say. At a temperature of 200 Kelvin. Bonus, convert your answer to millimeters of mercury. So this is just a basic PV equals nRT problem. So I'm plugging everything in. I don't know my pressure. I do know my volume. I know my moles. I know my R, and my temperature is already in Kelvin. So if I divide both sides by 2, then I'm going to get 24.6 atmospheres. Okay, now that's the answer. But if you wanted the bonus to convert into millimeters of mercury, on your red paper, it says that there is 760 millimeters of mercury for every 1 atmosphere. So then you would just multiply by 760, and it's kind of a lot, right? Because this is a really high atmosphere of pressure as it is. Number 3, it says a 2.5-liter container will hold approximately 4.4 grams of which of the following gases at standard temperature and pressure? And then it gives you those conditions right here. Okay, so whenever you're trying to figure out what gas, you're trying to figure out the molar mass, right? So we know the formula for molar mass is grams per mole. So we are given grams, so we just need to calculate moles. So I'm going to be using PV equals nRT. So I have my pressure of 1 times my volume of 2.5 equals moles. And then I just divide both of them by this. Okay. And then I would get 0.11159 moles. So then in order to figure out the molar mass, what I would do is I would take my grams, right, which is 4.4 given to me in the problem, divided by my moles of 0.11159. And if you do that, you should get 39.43 grams per mole. And if you look on the periodic table, that matches up with the molar mass of argon. Okay. Number 4, this one's a little tricky. A gas mixture at 25 degrees Celsius and 2 atmospheres of pressure contains some methane. So we don't know how much methane, it tells us. It says some amount. 2 moles of oxygen and 3 moles of nitrogen, and a total of 3 moles of gas. How many moles of methane are in the mixture, assuming ideal gas behavior? So guys, it tells you how much total there is. It tells you all of the other parts, so the rest of it must be methane. So all you do is you do 6, right? Because that's my, wait a second. So sorry. Okay. So this is wrong. So this should be 3 moles. I see. Problem from ChatGPT. Problem. Okay. So let's assume that this is 6 moles of gas, right? Because this number has to be higher than these 2 numbers. Otherwise, the total wouldn't make sense, right? So anyway, what I had written was correct. If this is 6, right? So we have a total of 6 moles equals methane, right? Plus my moles of oxygen, plus my moles of nitrogen. Okay, so then if I add 2 plus 3, that's 5. So that means X would equal 1 mole of CH4. Sorry about that. I'll put that in the chat for you guys to change this one to 6, because otherwise it just won't make sense, right? The total has to be bigger than the sum of all of its parts. Okay, what is the partial pressure of methane? So this is when you're going to be doing part over whole multiplied by the entire pressure. So my part is 1, my whole is 6, right? Because I changed it to 6. And then you're going to be multiplying that by 2. Why 2? Because that is the overall pressure, right? So if you do 1/6 times 2, that's going to be 0.33 atmospheres. Okay, last one. Says a 20-gram sample of carbon dioxide gas is placed in a 30-liter container at a temperature of 350 Kelvin. What is the pressure of the gas in that container? So this is just a PV equals nRT equation. However, you're given grams. So what you're going to have to convert that into moles, which you can do because you know what compound it is. So that's the very first thing I have. So I have 20 grams divided by 44 grams because I took 1 carbon and 2 oxygens on the periodic table, added those up. That technically be 44.01, but whatever. And that equals 0.45 moles. Then all I have to do is use my PV equals nRT equation. So I'm solving for pressure. I'm given volume of 30 liters. N is 0.45. I just solved for that. Multiplied by 0.08206, which is R, and multiplied by 350 because it's already given me the temperature. Divide each side by 30, and you should get 0.435 atmospheres. Okay, hopefully that was helpful.